When you're working with word problems and trying to convert them into some algebraic equations to solve, one of the big points to remember is that you only want to solve equations that have one pronumeral, so an x or a y. We're actually going to use a k in a second, but what we don't want is x's and y's and trying to solve for more than one pronumeral, because as you've just been practicing in the guide, we only solve with one letter or one pronumeral. So all of this information here we need to write in terms of one letter. Now the learning guide uses Joe's age. I want to show you a different way. So even if you haven't read the Joe's one yet, you can then go back and have a look. So I'm going to say that Kate's age, so Kate, not the person, but her age, we'll use K so that we remember it belongs to Kate. That's the number that represents Kate's age. Now the information I have is that Gabby's age is twice whatever Kate's age is. So whatever Kate may be, Gabby is actually 2 times bigger, 2 times K, or 2K. So I can describe Gabby's age as 2K. Joe is 3 years younger than Kate. Now if you read the original question, it talks about Kate being older, but I'm interested in describing Joe's age. Joe is younger than Kate, so I need to take Kate's age and get rid of a few years to find out what Joe is. So when I talk about being younger than Kate, I need to subtract or take away the extra years. So Joe is actually Kate's age, take away 3 years, because Joe has to be less than Kate. So Joe could be described as whatever Kate's age is, and then take 3 off it. You'll get Joe's. Brett is 4 times as old as Joe. That's Joe's age there. So we want 4 times as old as Joe. And Joe is whatever Kate is, take 3 away. Brett's 4 times whatever that is. And we're not concerned that we don't know it yet. That's okay. So I have, if I write it a bit more closely, 4 outside of K, take 3. You can expand those brackets if you wish. I'll just leave it for now. 4 lots of Joe's age. Now I know the sum of Kate's and Brett's age is 63. Sum tells me to add them up. So I'm going to remember that. So Kate's age is K, plus Brett's age, this big mess over here, but that's okay, is equal to or is worth the same as 63. So I've aimed to very slowly step out everything I know in terms of K or Kate's age. And you could use anybody's age, but just stay with one letter. Don't go introducing a G, a K, a J and a B, or you just get a whole lot of unrelated equations. That's no good. Okay, I'm looking at this equation here. K plus 4 lots of K take 3 equals 63. And I'm thinking I can solve for K. I've only got one pronumeral. It's in 2 spots, but I can sort that out. So I can actually solve and find out how old Kate is. And once I can do that, I'll be able to figure out everybody else from there. I can't start undoing anything until I sort out this big mess here. That's a very messy side. So leave this K alone, and I'm going to use my distributive law of multiplication over subtraction to expand this little part of my expression. So K is going to be added to this, which is 4K, and 4 by 3 is 12, and I've still got a subtraction there. 63, it's still worth the same as this. Okay, still not solving, still just trying to tidy up what I've got. 1K and another 4K, these are like terms, is actually 5K, still take away 12, still is equal to 63. So up until this point I'm not solving, I'm just trying to tidy up what I've got. And once you've done that, now I can start undoing some things. I'm going to undo this take away 12 by adding 12 to both sides, keep that equation equal. taking 12 and adding 12 to a number means you've undone that operation. So I'm left with 5k on this side. Over here I have 63 plus the extra 12 to keep my equation equal, that's 75. Next step, I want to undo the operation from k that produced 5k, and k has actually been multiplied by 5 in this instance. So I'm going to divide both sides by 5. You can use the division symbol, but this way is a bit more sophisticated. It's a good way to get used to if you can, because I can very easily see my cancelling here. I've now got k on its own or isolated. That's good news. I'm close to solving for Kate. 75 divided by 5. You can either do it in your head or actually set out the algorithm if you're concerned. 5 into 7 goes once and 2 left over. 5 5s make 25. Your call. Either way, we have just found out that young Kate is 15 years older. So Kate is 15. A lot of the hard work's done now because we set ourselves up so nicely to write everybody else in terms of Kate. Gabby is 2 lots of Kate. Gabby is 2 lots of 15, or she's 30 years old. Jo is whatever Kate was and 3 less. So Jo is 15, take off that extra 3 years, which is 12 years old. Brett is 4 times as old as Jo. So you can either put Kate's age in there if you want to, or I'm just going to use Jo's age. Brett is 4 times older than Jo. 4 by 12 is 48. If you chose to use Kate's age, this is what it would look like. 4 lots of, Kate was 15, 15 take 3, which is 4 by 12, exactly what we had, which is 48. So either way is okay, still gets you to the same spot. And then you check and you go, is this reasonable? So Jo's got to be younger than Kate, he is. Gabby's got to be twice as old as Kate, so Gabby has to be much older than Kate. 30 compared to 15, that's good. Brett, he's our old man. He's 4 times older than Jo, so he can't be like 10 or something. He's got to be a decent age, and in this case, he's 48. That's not so old. Okay, and so now we've checked. If you wanted to, you could do some substituting to double check. Or you could, solve for Jo, which is how you see it done in the learning guide. So there's lots of ways to get to the answer, but strongly recommend stick to one pronumeral, one letter that you think relates to lots of information, and describe everything in terms of that letter, and life is a lot easier than trying to work with lots of different pronumerals.